The low-frequency Longview quake we had a couple days ago near Mount St. Helens sits on the Oregon coastal block of the Juan de Fuca plate. It's on the Columbia River, and it sits on a number of faults, horizontal and vertical. This is an area that is very seismic. It's in the lane of the Cascadia arc of the Juan de Fuca plate, and it's in a very seismic region, and the high threat volcanoes are all there from north to south. We just had a low frequency earthquake in Longview, which is a city in Washington at the border with Oregon, and it's basically on the north side of the Columbia River, as you can see here. Columbia River is not far, Longview is not at all far from Mount St. Helens, where we've been having a tremendous amount of quake swarms lately these past few months. And it's not far, it's about 20 miles from what I remember. Okay, 30 miles, sorry, 30 miles. So what is so strange about Longview? It's a very small earthquake, but we've had swarms of earthquakes in this very high threat volcanic area, Mount Hood and Mount St. Helens. That is a very, very threatening volcano, one of the worst in the world because of the proximity to a very populated area, Mount Rainier, and Puget Sound, where we've had a tremendous amount of earthquakes lately. And what about this tiny earthquake in Longview? What's so special about that? Well, it's right in the area of Seattle, Washington, right there, Puget Sound. This thing here is one of the worst faults that would give a megathrust earthquake of higher than 7.58 magnitude, and in the past it has also given tsunamis. Now, if you remember, July 3rd we had a 6.2 magnitude earthquake that hit north of Vancouver, Bella Bella, Canada, and that hit immediately 13 hours later in Ridgecrest, South California, right there. And my pin is gone again. It's right there, okay? And we've already established, even though geologists say that the Seattle earthquakes don't have anything to do with Ridgecrest, that's not so, because we've already established by the U.S. Geological Society their paper that was published, and I'll give a link to you on that, having to do with a fault line that nobody is talking about yet. Because if you talk about that, then you may have people saying, well, maybe it's time to get out of Dodge. Because this is the Walker Lane fault. This thing, as you can see, this ridge of mountains, parallel to San Andreas, inland, this is all of the Walker Lane fault system. It's not one fault. We said San Andreas is the longest in California, then Garlock, which is zip-locked over there, where we had the Ridgecrest earthquakes. This is a fault system that acts like one fault, but it's a series of faults. And in fact, the two earthquakes that we had here, July 4th and July 5th, the 6.4 and the 7.1, Dr. Lucy Jones of Caltech, the geologist, told us that both those quakes were on two different faults. And the geologists are scurrying to find out how each one of those faults is going to behave in the future, because they were pretty major quakes, and how they would also work together. Well, we've already seen that we're having an average of about 1,500 quakes a day there, which is in a volcanic field. It took them 3 days to tell us it was in a volcanic field, the cause of volcanic field, but they never yet mentioned the Walker Lane fault. This thing here goes like this, and you can see it very nicely on Google Earth. It shows itself, and basically it goes like this, into the Juan de Fuca plate, and it's propagating north. And you can see that we've got a number of high threat volcanoes there. We've got the Long Valley, which is a supervolcano, which in fact, this Long Valley also takes in Clear Lake volcanic field, which has had, I think yesterday, 27 quakes. And Lassen Peak, Mount Shasta. This thing here is the Cascade Arc. That has its own huge high threat volcanoes. Mount Hood, which is active, Mount St. Helens, which has been active for months, and Mount Rainier, which is right near Seattle. And this is our area that we're looking at, Longview. I want you to see the map. Okay, this is the Seattle area that we told you that this fault line gives a megathrust. And this is it right here. Sorry, I can't go in. That's it. You see that little squiggle there? St. Helens, that is Longview right there. And wherever you have, you'll see, wherever you have rivers, you have fault lines. Just keep that in mind. That's one of the first things we learned in geography, remember? That's the very severe fault line that runs Puget Sound, Seattle area. I just want you to know that that's a very worrying sign. Okay, Washington fault line map. And let's keep going down so you can get the idea of what's happening. That's it right there. You can see it more clearly. And where they gave us the 4.6 and the 3.5 aftershock. And now we're heading into that's the Seattle fault. We're heading into our area. Right there. You see that little tick up? Right there, that's the river, Columbia River, and these are the fault systems of the Cascadia subduction zone, and you've got the perpendicular faults going in. It's sitting on a fault. You'll see it more clearly. As we head down, I'll leave you a link below for this, of course. That again is the high threat area sitting over Seattle for the mega quakes. And let's go here, somewhere down here. We're close to it now because it popped off my screen. Okay, that's the Juan de Fuca plate aftershock zone. Okay, and you can see the volcanoes, all those little red triangles. Okay, subduction zone, volcanoes, Cascadia subduction. Okay, keep going. That's it. Let's go. Here we are. Where's our little tick? That's our little tick. There's Longview right there. That's Longview on the Washington side of the river of Columbia River, and this is Portland. This is Oregon. Okay, and this whole thing, as you can see here, the border. This border is the Oregon coastal block. This is called the Oregon coastal block. On the right, you have the subduction. That's what these little crests mean. And on the left, you have the high threat volcano Cascadia arc on the Cascadia arc, and all these little red things are, of course, earthquakes. Now, upper plate earthquakes and post 15 million year faults. You can see the big earthquakes here, also here. And that's Longview. That's the Longview area right there. And this is Mount St. Helens. Oop, there we go. It's off again. It pops off for some reason. It just pops off. Let's go running down. I guess we can find it. Where we are, we're close now. Okay, close to the bottom. Here we are. And you can see it's on a fault line. It's on faults. Whether you want to call them horizontal or vertical, you take your pick. And that's it right there. That's the area right there, and with our volcanoes. Upper plate earthquakes and post 15 million year faults. Volcanic vents, 0 to 5 million. You can see them right here. Northern compressional arc, seismically active, low extrusion rate, low heat flow, folded basement, small 4-arc rotation. The central extension arc, low seismicity, high extrusion rate, axial graben. Southern transtension arc, seismically active. Okay, this is why we see a lot of earthquakes up there and a lot of earthquakes down here, and low seismicity in the middle. Remember we used to see that at Pacific Northwest seismic monitors? Let's go to our plate tectonics. No, I want to go here. Okay. Tremor map, RPNSN. Hopefully we'll wake up soon. Okay, this is it right here. Okay, Seattle, and we said that we have low seismicity in the middle, and we have high seismicity. You can see it here. This is the way it was. And let's go here. Okay, this is what I wanted to show you, having to do with the Western United States. This is San Andreas Fault, SAF. This is GF is Garlock Fault. The ECSZ is Eastern California shear zone that we hear the geologists keep talking about, that this is the area that will be very active. That, of course, that's in the causal volcanic field. And then we have WLB, which is basically this whole thing. The Eastern California shear zone is part of the Walker Lane Belt. Okay, and that thing is what's pushing up to the Cascadia arc. That's what I wanted to show you, and I'll leave a link below for you for this, because it shows you that it's definitely connected in that it's propagating itself north. So every time you get a quake up there, you're going to definitely have it quake up there, you're going to definitely have it hit here and go there. This is exactly what we saw July 3rd, the 6.2 magnitude outside of Vancouver Island, Canada. Unfortunately, they don't talk about that because it's another country. It's Canada. But the thing is, it's only, about 100 or 200 miles from Seattle. And it's on the same fault line. So you can't ignore that and not say anything about that, because 5 years ago, again, they had a 6.2 out here, and 24 hours later, it hit exactly at Ridge Crest in the causal volcanic field. Anyway, I wanted to show you that. Let's see if our things are awake over here. Here it is. Okay, it's the recent earthquake list of Longview. We have Newberry, of course, is very active. But this is Longview right here, the 2.1 a couple of days ago. Distance of 26.4 kilometers. That's about 17, 18 miles. Depth. Sorry, that's the depth, 7.6 kilometers. That's the distance from Longview. Okay, that's the depth. And what caused it? It's on a fault. Okay, here we have it. It's on July 11th. Okay, July 11th. Distance from Longview, about 16 miles. Depth of about 4.5 miles. Okay. And we saw that it was, of course, on a fault. This is this starts at 2016. We'll wait for it to come up again. 2006, sorry. It'll start. There it goes. There it goes. This thing here is Yellowstone. That's Yellowstone. The subduction rate of the Pacific Plate under the North American Plate is about 38 millimeters every single year. So you can see why we have such a tremendous earthquake activity in this area. Okay, so this is the area that we're looking at that had the earthquake. This thing with the little uptick there. That's it right there. Our location is Longview. Let's go in again. Right there on the Columbia River, right next to Mount St. Helens, which is erupting just about 30, has quakes about 30 times, it's quaking 30 times a month, 30 quakes a month. And let's see if we can get to that. Oh, no, we're not going to open that. Okay. Mount St. Helens. Last 2 hours. Okay, that's the crater, and it's basically on the eastern side. Okay. It had 2 yesterday, basically 1 a day, as you can see. Okay. Basically 1 a day. Total 81 for the last 30 days of events. So it's not 30, it's 81. Let's go out. And imagery. There you go. That looks a lot nicer. You can see very clearly where the cone is. Okay. No, I wanted to go out. And that's Longview around here. Longview is around right at that bend. Okay. Around here. As we said, 30 miles from the volcano. I'm not saying it has anything to do with the volcano, but it does have to do with the Oregon coastal block and the faults that it sits on. Basically, running along the river. Take your pick. You want horizontal faults, you want vertical faults, they're all there. And of course, it does have seismicity. So I'll leave links below for you for this. Thank you. Now, what I'm trying to establish here, and if you have the patience to go and see my videos that I posted yesterday concerning the quakes in this area, that the Walker Lane faults are propagating north, pushing on the Cascadia arc, and that's why the Cascadia earthquakes take a couple of hours to come down and hit here at this area that we see on the right, the Coso volcanic field. That's a picture of the Volcano Peak volcano, and the lava is very nicely was running towards the Ridgecrest area of South California. Now these are the high threat volcanoes that you can see running all through the Cascadia arc, all the way down into California. So I don't know why they're not referring to the Walker Lane faults, and why they're not connecting the Cascadia arc with the Walker Lane fault system, because it is connected. And here's the map showing it. The little red stars are the Walker Lane belt that starts from Ridgecrest going all the way up, and of course propagating to the Cascades arc. Okay? And you can even see the Columbia River. It's going through, very close. It's going through Mount Hood, Mount St. Helens, and of course around the Longview area. If you'd like to join me on my Patreon account, you will hear content not covered by mainstream media. These riveting stories will be based on my research, and I will state my opinions and give my personal insight on diverse and controversial subjects and world events not covered by mainstream media, and not supported by YouTube guidelines. So whatever I have on my Patreon, most of those will not be on my YouTube channel. Please consider becoming a member today. More of the most significant and important videos will be on my Patreon channel. Your support helps me to continue my research and keeps this YouTube channel alive. And we depend on your support, your generous charity, because we help economically challenged families here in Athens, Greece, in Kapota, and we also help the young generation with university tuition and the community around our church. Thank you.